Welcome. This is the second episode in the series, Small Business, the Fourth Industrial Revolution and a Map. I'm Ross Sievertson, technologist and executive. In the book, The Fourth Industrial Revolution, Klaus Schwab notes about the advances in coming technology that they all share one common characteristic. They all share the pervasive power of digitization and information technology. So yesterday, I posted the third article in a series where we discuss the mega trends that are the drivers behind Industry 4.0 and the effect that it has on small business. So my goal here is to give you all some takeaways that I hope you'll find valuable as you continue to plan the growth of your enterprises. Now, these megatrends are organized into physical, digital, and biologic systems and their related technologies. All collectively benefit from the advances that are made in each. So we'll start by looking at the megatrend of physical systems and its related technologies of autonomous machines, 3D printing, advanced robotics, and new materials. We'll start with autonomous machines. So when I was at CES 2018 earlier this year in January, as I was walking around the exhibit halls, you couldn't help but notice the emphasis that was placed on autonomous machines. Now, when we think about autonomous vehicles, we tend to immediately go to the driverless cars that are developed by Google and Tesla. But autonomous machines take on many different shapes, everything from, drones to boats. And the technology behind autonomous machines is advancing at a breakneck speed. Let's take, for example, a driverless car that's developed by the company NVIDIA. So yes, NVIDIA, the same company that manufactures graphics cards that are found in many modern-day personal computers. Well, it turns out that the family of processors that are used in those graphics cards to render photorealistic environments like those found in the personal computer game Far Cry are also good for other purposes, like developing artificial intelligence applications for the driverless car I just mentioned. Okay, so the AI in this system, to call it a computer program is a gross understatement. It never received instructions from a programmer or engineer. It learned to drive and operate a car by observing human drivers. Now, the challenges with this sort of become obvious when you consider that the engineers that designed this system really aren't entirely clear about how the AI makes its decisions about driving the car. Okay, so the takeaway is this. Autonomous machines and multi-use vehicles like those found in Toyota's e-Palette initiative will absolutely revolutionize supply chain, logistics, public transportation, and consumer retail. But it has to be balanced with the engineers designing these systems thoroughly understanding how the artificial intelligences that run these systems operate. Okay, so now we're going to talk about 3D printing. I remember when I first saw a stereolithographic rapid prototyping system in the mid-1990s, it seemed almost magical. It pulled out a part from a vat of goo that looked like something out of a science fiction movie. It used ultraviolet light to cure liquid resin. The parts that it manufactured or produced were about 25 cubic centimeters, and they were both fragile and expensive, each of them costing several $100s. The system itself was the size of 2 4-drawer filing cabinets and cost about $200,000. Okay, so fast forward to July 2018. So I'm a hobbyist-based guitar builder, and I needed something to produce prototype control knobs going onto my builds. So I did what any self-respecting maker would do, needing to add technology to his arsenal. I went down to the local big box computer store and I bought a 3D printer for about $400. Now, this 3D printer uses materials from anywhere from ABS and PLA plastic to carbon fiber and wood to produce the parts. The additive manufacturing processes that we're currently finding today have the ability to produce near production quality parts at a fraction of the cost that was available even a few years ago. Consider the processes of direct metal laser sintering. Wow, try to say that several times fast. It uses a high-powered laser to literally melt and fuse metal alloy powder into metallic parts that are used in everything from medical applications to aerospace. Okay, so the takeaway is this. Folks, 3D printers and 3D manufacturing technology is not science fiction. It's here today and it's becoming more affordable all the time. The advances that are being made behind this technology is occurring week by week. I can imagine that no longer will a repair depot need to carry an inventory of replacement parts. You break the knob, you need to have a replacement knob for the one that broke on your oven or gas range in your kitchen. Or maybe you need one of those little plastic clippy things that hold up the shelving in your cabinets. Well, you just download the models and print them on a 3D printer that are right next to the inkjet in your office. These technologies are going to revolutionize how we look at purchasing, procuring, and manufacturing parts. So I can imagine that in my house, there are very few replacement parts that I will need that can't be replaced by 3D printed parts. Okay, folks. Wow. So thank you for sticking around. We'll continue to unpack these technologies and sort of give you information about how it affects small business. In the next episode, we'll continue to talk about the physical systems and the additional technologies of advanced robotics and new materials. If you find that this series is of value to you, please click link and subscribe below that you find down here. And if you have any comments, folks, I really find all of your feedback valuable. Make a comment in the comment section below, and I promise I will respond to every comment. So until next time, this is Ross Sievertson. We'll see you again. Thanks for watching.